No matter who you are, no matter how old you are, you've definitely heard about ether. For most people, this word immediately brings to mind the so-called radio ether, a space in which radio and television broadcasts are transmitted. Some are familiar with the chemical concept of ether. In particular, organic chemistry is built on ether bonds. It would seem that these are absolutely different concepts. But there is also a third meaning. This is the so-called luminiferous ether, that is, a certain invisible and imperceptible substance that permeates the entire universe and is absolutely everywhere. And it is this that scientists have been searching for and cannot find for centuries. Now, this substance has been replaced by quantum physics. Maybe they just got tired of searching, or maybe some unknown force is resisting these searches. Anyway, about the history of ether searches, about the forces that opposed each other over the centuries of history, and why quantum physics was invented at all, I told you in the last film. And now let's try to focus specifically on the ether. Let's try to figure out what it is, why it constantly slips away from our attention, and how it differs from the usual matter we know, if it exists at all. Good day, you are on the Epoch of Disbelief channel with Mikhail Kalmykov, and we are heading into the fantastic world of ether. As we found out with you in the last series, for more than 300 years in the scientific world, there has been a silent, undercover struggle for the destruction of the very concept of ether. It went on with varying success and with the use of any available means. They did not even shy away from banal trolling by royal personalities and other power holders. Remember at least the many years of attacks on Thomas Young by the British Prime Minister or the support of Newton by the English Queen. Nevertheless, the wave theory of light, along with the theory of the existence of ether, sometimes held very significant victories. The last victory was held by Thomas Young with his double-slit experiment, and it lasted almost 50 years. Yes, and even after its overthrow, the victory of the corpuscular theory was not final, and it was necessary to invent a chimera called quantum physics, into which everything that did not fit into the classical understanding of physics was dumped, like into a black hole. And all this effect was given an almost magical status. But even after this, there was no full and final victory over the double-slit experiment of Young. And it was necessary to introduce the concept of corpuscular wave dualism, where magic was again actively peddled, in particular, the observer effect. Without the slightest attempts to understand why, exactly, light sometimes behaves like a wave and sometimes like a particle. We have already understood with you that the magnetic field in which a beam of light or a bunch of electrons was placed simply exerted some stabilizing influence on it. In fact, almost all physicists understood this before us. There are a huge number of revealing videos on the internet, but they are not popular. Because the observer effect is so fantastic and captivating, even the physicists themselves decided to complicate this experiment to the limit, as if not only confirming the magical observer effect, but also introducing a new, even more magical paradigm, the so-called quantum leap. And as much as I wanted to move on to describing the ether, it is impossible to bypass this experiment. It is called a quantum eraser with delayed choice. I understand that the description of the experiment is quite complex, but I will try to explain it as clearly and simply as possible. You understand that complexity and distraction with numerous details is an inseparable attribute of a focus puller. And if the task is to show magic, then real professionals take on the job. So first I'll explain what the essence of this trick is. The experiment was conducted by a group of scientists led by Yong-Ha Kim from the Department of Physics at the University of Maryland, Baltimore, United States of America. By the way, our compatriot physicist Sergei Pavlovich Kulik was also a member of this group. At the core is a typical double-slit experiment by Young. As in it, light passes through two slits in separate beams, ideally separate photons. But since the particle detectors standing near the slits discredited themselves, and the scientists understand this perfectly, they decided not to install any sensors immediately after the beam passed. After all, as we clarified with you in the last film, the detectors themselves directly influence the particle as a result of the position measurement. And most likely, the observer effect is directly related to this influence. Therefore, in the new experiment, instead of measuring sensors near the slits, a crystal is placed that splits the beam from any slit into two, followed by a complex system of prisms and mirrors. The physicist's idea is that after the photon passes through one of the two slits, we still don't know which one it went through, since there is no sensor. Then the photon splits into two parts with half the energy, each of which goes into a focusing lens and then hits a passive detector. Something like photographic paper. That is, there is no influence of the electromagnetic field from the sensor. This detector is the first one, and the photon hits it right away. The second photon has a longer and more complicated path. It goes through another prism, then through a semi-transparent mirror, and only then to the next sensor, more precisely, one of the two sensors. And thanks to this, we get precise knowledge of which slit the photon passed through. And because it takes the photon another 2 nanoseconds to travel this path, after the first photon has already hit the target, it seems that the observer has no influence on the first picture. After all, it's already in the past. The photon has already hit the target there. But the path of the reserve photon does not end there. Some photons pass through this same semi-transparent mirror, and after a couple of nanoseconds hit this fully reflective mirror, which reflects them back into another semi-transparent mirror. And only after this, the remaining photons hit the third final row of sensors. The third row is needed precisely to scramble the information again, through which shell the photon passed. We get such a picture step by step. First step, the laser shoots a photon towards a slit, but we still don't know through which slit the photon passed. Second step, part of the photons draws a picture on the first main sensor. Third step, with the help of a reserve photon, we find out through which slit the first photon passed, and again we see a picture on the sensors. At the moment when we already know exactly through which of the slits it passed. And the fourth step, this is again confusion, that is hiding information from the observer, and again sensors showing a picture already after the confusion of information. And what do we get in the end? In the end, here's what. At the moment when we know exactly through which slit the photon has passed, the sensors draw two clear stripes, more precisely, on each sensor. There is one stripe corresponding to each of its slits. But if they are combined, then exactly two stripes are obtained, without interference. On the next step there, where the information gets confused, that is, it is erased so much that it is impossible to trace it, the sensors again draw an interference pattern. Bingo. The observer effect is proven, without any electromagnetic fields, only with passive sensors. We see that when we know which slit the photon has passed through, it's a particle, and when we don't know again, it's a wave. But the most interesting thing is imprinted on the very first sensor, the one that is ahead of all others. At the moment when one of the pair of photons just gets there, it creates an interference pattern. Then when the paired photon hits one of the sensors after 2 nanoseconds, and we find out which slit it went through, it draws a clear stripe on the sensor. And attention to the last number, that is, in the past, changes the picture on the first sensor to 2 clear stripes. Then after another 2 nanoseconds, the remaining photons fall into what is called a delay line, that is, a corridor of mirrors and prisms, which makes the determination of the photon's passage again uncertain. And then the photon again draws an interference pattern on the sensor, and its twin photon, again retroactively, that is 4 nanoseconds in the past, changes its interference picture. As a result, both patterns are displayed on the first plate at once, an interference and 2 clear stripes. Sensation. For the first time, we see an interference picture and 2 clear stripes superimposed on each other at the same time. That is, it turns out that photons somehow receive information from the future, whether we will observe them or not, and accordingly, either a wave or a particle hits the sensor. They wanted to prove the observer effect, but they got pure magic instead. And time travel, in any case, this experience teaches us so. And they've already named this effect quantum elastic with delayed choice. Consciousness is capable not only of turning wave into matter, but also of changing the past. For naive laymen, it could quite pass for a sensation. But what if our attention is being cunningly manipulated here as well? Let's now observe the magicians of science more closely, and for a while, forget about magic and sorcery. Look at this. The first sensor, both particles and waves hit it, but there's no effect on the photon beam at this moment. So we are told and we obediently listen. However, at this very moment, right under our noses, they are spinning a rather complex scheme of an experiment on which it is clearly visible that the beam passes through a lens before hitting the first sensor. Will anyone say why it is needed? As Yonho Kim himself said in his work, the use of a lens is intended to achieve the condition of a far zone. Then how is the short distance between the shell and the detector still maintained? Well, yes, the distance is too short, but push it further after all. Why do you necessarily need to put a lens? And yes, in front of the other sensors, which are by default located a bit further, there is no such lens. Maybe the distances are too small or too large? No, they are normal. The first sensor is located about 1 meter from the shell. The rest, accordingly, at 2 and 3 meters. Not too close or too far. For a laser beam, it's not a big deal. But for a photon, it's a particle, right? Why focus it? Take one separate particle? Does this explanation seem stretched somehow? Moreover, I don't know about the far field effect, but any lens definitely focuses the beam. But why focus the beam? In the experiment in which we specifically want to look at defocusing interference. Okay, let's assume. But the rest of the beam goes to the first sensor without any distortions. Again, no. Passing through one of the slits, the beam first hits the crystal. Yes, not a simple one that you can buy in any store, but a special one. This is the so-called beta barium barotte crystal, actively used in nonlinear optics. This substance was discovered and obtained relatively recently at the Fujian Institute of Material Structure Research of the Chinese Academy of Sciences by the Chinese physicist, material scientist Chen Chuan-Tian. Quantum physicists are thrilled with this crystal and use it everywhere possible. For example, they photograph quantum entanglement with its help. The essence of this crystal is that when a beam of light passes through it, it splits into 2 weaker beams. Or a photon with high energy splits into 2 entangled photons, each with half the energy. It is assumed that this influence of the crystal itself on the beam ends here. Although, in my opinion, this is already more than enough. Just marvel at the beauty of the formulation. A photon, that is, a quantum of light, which by definition of the same Max Planck is the smallest and indivisible portion of energy, is divided into 2 photons. Once again, indivisible is divided into 2 parts. That is, at a minimum, goodbye. Spectroscopy and half of astrophysics and astronomy which are based on the fact that the energy of a photon is absorbed and emitted completely by a single finite and indivisible portion. Nevertheless, a fact remains a fact. Before hitting the lens and then the sensor, the beam undergoes a very strong structural deformation in this very crystal. And after saying this, to say that there was no effect on the beam before it hit the sensor is simply impossible. There certainly was an effect. By the way, the beam or photon does not split in this crystal 100%, as it might seem. The efficiency is only 4 to 5 pairs of entangled photons per million. This is a very important nuance because it means that after passing through this crystal, the beam begins to consist of a kind of salad, where the main mass is still the same ordinary light. But now it contains structured, so-called entangled photons in a very, very small quantity. Nevertheless, they are there. But that's not all. Immediately after the beta barium borate crystal, the beam hits Glenn Thompson's prism, which splits his beam or stream of photons into 2 parts, according to their polarization. Half goes to the left at an angle, the other half goes to the right at the opposite angle. Are you saying there's no effect on the light again? Then what was that just now? So, I'll take a risk and assume that without the lens on the first part of the path, only the interference pattern will remain, and the 2 stripes indicating the presence of particles will simply disappear. After all, they are formed as a result of the action of crystals and lenses. It focuses such a small amount of structured photons at one point, which is how the absence of interference is achieved. And with the disappearance of the lens, all the magic of deferred choice, all the fantasy of quantum plastics simply disappears, vanishes. The further path of the second duplicating beam no longer plays an important role. However, let's figure it out too. Before hitting the second row of sensors, the light beam also passes through a triangular prism, then hits a semi-transparent mirror, and only then hits the sensor. And again, the question is, why is there a prism? Does it do nothing at all? It seems from the diagram that it changes the path of the beams towards the semi-transparent mirrors. But if you remove this prism and slightly shift the mirrors with the sensors, the effect will remain the same. In any case, it should remain because according to the definition and conditions of the experiment, the prism does not have any effect on the beams or photons. Then what is it for? Let's turn again to the work of the author of this experiment, Yonha Kim, and see what he himself writes about the use of this prism. Nothing. She just is. Calm down. No. Of course, one can assume that it simply diverges the path of 2 laser beams slightly to the sides, since the distance between them corresponds to the width of the slit. That is 0.3 of a millimeter. But we are talking about individual photons and the speed of light. 0.3 of a millimeter for such quantities is just a gigantic distance. Further along the path of light, there is another obstacle in the form of a semi-transparent mirror. It reflects half of the beam onto a sensor and lets the other half pass through itself. At this point, everyone is talking about a 50% chance of the beam being reflected or passed through the mirror. Either it will pass or it will reflect, but how so? We're discussing probabilities. Stop. In ordinary life, such a conversation is quite possible. But at this moment, we're talking about an experiment where everything is calculated with precision to a single photon. The beam passing through the beta barium borate crystal will be precisely split into 2 halves. Crystals, lenses, mirrors are all meticulously selected. The polarization of each beam, its saturation with entangled photons, its energy, spin, and a host of other data are known and verified according to meticulously selected formulas. And suddenly it either will happen or it won't somehow. Moreover, the light beam has to pass through at least 2 more semi-transparent mirrors and at least 1 full mirror. Something is not right here. It can't be that everything in this experiment was somehow haphazard and correct. Here's what the famous science popularizer Boris Boyarshinov says about this experiment.
But it should be said that the same photon can be split, that is, it can pass through 2 holes. Either it will fly into one hole or into another hole. Well, these are 2 shells, let's say, Jung's experience. That is such a transformed Jung's experience. And it will quietly interfere there. Now you can spoil this interference. Put a polarizer. The polarizer is strictly our wave nature. The photon here should be used. Well, the light is polarized, maybe. What is light? Electromagnetic oscillations are not particles, but oscillations of the electromagnetic field. Photons can be polarized. You put the transparent one, polarizer. They make them like this, 2 glasses, between them a thin polymer in which crystals, iodine or something of the sort. They are oriented, so they only let through waves of a certain polarization. Let's say like this. Directed, let's say conditionally, the electric vector is oscillating in this plane. Here he comes. Now if light falls and it coincides with the plane of polarization, it passes through to the maximum, plane of polarization. You turn and the light already passes at an angle, polarized, and here you had non-polarized light at the entrance or polarized at an angle. It will squirm for you. It will be perpendicular. Nothing will pass in the plane at all. That such things will be. Well, okay, good. So be it. And there's more. It's called circular polarization. Do you understand what's the matter? So, 2 waves. You can imagine 1 photon, but circular polarization is a nightmare. This means that your 2 waves coincide and slightly differ from each other. They lag behind just a little, they lag behind. Well, let's say for some part of the general period. These 2 sinusoids will be superimposed, and it will turn out that since they oscillate, 2 sinusoids are directed perpendicularly. This will be circular polarization, it's called. Here it goes, this wave, and it's polarized in a circle. It's called circular polarization. There they put circular polarizers, and that's it. There's no interference. They don't feel like they need to interact in 2 receivers at the same time. We put everything there, the polarizer, everything is there again. That's why they call it quantum rubber. I don't know, maybe it's just a fashionable word, maybe there's something in English, there are some allusions. In my opinion, this is just another demonstration that radiation is, on the one hand, electromagnetic waves, and on the other hand, a stream of photons. Well, something like that.
Polarization, that's the whole point. Thanks to the polarization of light waves, the mirror decides whether to let it pass or reflect it. That's exactly how, for example, polarized glasses work. It turns out that semi-transparent mirrors act as filters. Polarized, that is, structured coherent light, the mirror will let through, and non-polarized will reflect. And at the same time, it will reflect and scatter photons born in the beta-barium boron crystal. As a result, non-coherent, non-polarized light plus photons will give a clear picture, literally from particles on sensors D3 and D4. And the coherent light will pass through the mirror and, having reflected a couple more times, will give an interference picture on sensors 1 and 2. Now pay attention, one more trick. Why is further entanglement of information about the photon's path necessary, according to the type of experiment, in order for this information to be erased in the universe? Bold statement, but personally, I think the universe has nothing to do with it. Does any one of us know through which slit the photon passed or not? But it matters to the experimenters. They need to create the illusion of complexity. They talk again about the probability of the second mirror reflecting or letting the beam pass. But let's look at it from a different perspective. If the beam has already passed through the first mirror, then it will pass through it a second time with 100% probability, not half. And in any case, it will hit sensor 1 or 2, and with the same 100% probability will give an interference pattern. But the experiment is set up in such a way that there is no way to tell whether this is reflected light or transmitted light. This, in fact, is not hidden in this puzzle, but someone is trying to prove that in this way we are confusing the universe. Then, in fact, they are confusing the viewers and hiding the tricks that speak of the falsification of results. Damn, Boson. In other words, the double-slit experiment is still relevant and directly demonstrates the wave structure of light. All the complications that quantum physics adepts come up with are nothing more than beautiful tricks that can be explained just as well in wave theory without quantum time travels and other intricacies. The main thing is to carefully watch the hands of the illusionists. In fact, they understand this perfectly well themselves. So light is a wave, and for the propagation of a wave, a medium, ether, is needed. And when the ether is strongly compressed, matter is born, a real substance. In physics, there is even a formula that describes this process. It's called the ultraviolet catastrophe, and it was precisely to turn a blind eye to this equation that quantum physics was invented. I've already talked about this in more detail in the previous video. It's called the light quantum chimera. But it's one thing to turn a blind eye and deceive the public, and quite another not to notice this in reality. Our civilization has come a long way since the times of Newton, and even since the times of Max Planck and Einstein. At the very least, many more tools have appeared, including computers, quantum ones, nuclear power, space flights. We simply had to encounter these effects in real life, if they really exist, and why not? After all, we have long had particle accelerators on which we accelerate various protons to tremendous speeds and collide them. By itself, I mean the Large Hadron Collider and the famous Higgs boson searches. On it, as well as on other colliders like the Tevatron, bunches of particles are accelerated to near light speeds and collide with each other. If matter is compressed ether, then such collisions must inevitably create substance, and it appears. You've heard that scientists have obtained the Higgs boson as a result of such collisions, haven't you? Of course, we were taught this a bit differently. This very boson was always somewhere inside the protons, but it jumped out during the collision and we captured it. Well, something like that. This boson was searched for very diligently because its existence completes the integrity of the standard model of elementary particle physics. In it, he is responsible for mass. That is, as if mass and its influence on other objects is carried out by this boson. And everyone was so pleased with his successful discovery that they immediately named it the God particle. Remember what a firework of joy there was in the scientific community then? And apparently no one thought to ask why it was specifically called the God particle. What is so divine about it? But they did ask, of course, but the answer was somewhat obvious. The joy of discovery. But now this name begins to shine in a completely different light. The thing is, upon collision, an interesting nuance arose. The mass and time of the resulting Higgs boson was 125 times greater than the total mass of the colliding protons. It's the same as if you bumped into each other. It's like if you collided two ordinary chicken eggs weighing 50 grams each, smashed them on a frying pan, and the resulting omelet would weigh a whopping 6.5 kilograms. Where does all this extra mass come from? Scientists, in response to this question, mumble something unclear about the Higgs field and the violation of symmetry in the standard model of elementary particle physics. However, if particles are accelerated to nearly the speed of light, it is quite likely that they will push the ether ahead of them, creating a front of ether wave. Colliding, two such fronts could well form something like a new particle. In any case, its mass will certainly appear out of nowhere, and as we see, quite a substantial mass. The second interesting moment is the existence time of this very particle of God. It's only 20 yoctoseconds, that is, septillionths of a second. To make it clear, this is a number with 22 zeros after the decimal point. That's how many seconds this very boson lives. It's not surprising, as it's not a particle as such. It's just two colliding fronts of the ether, two waves that almost instantly decay back. But the fact remains a fact. Scientists have created a new particle out of nothing, created matter. And that's why the Higgs boson was called a God particle. Because physicists have gained the ability or hope to create something out of nothing, they felt like gods. And not at all because this boson is the building material of the universe with such a continuity of life. No, this explanation is only for laymen. In fact, of course, they are not gods, and they are still very far from creating a real stable particle. But more on that a bit later. But for now, let's see what's happening in these colliders of yours on December 25th, 2023. Well, literally a week ago, an authoritative publication published the work of a team led by a group of researchers from Osaka University and the University of California in San Diego. In this work, scientists used modeling to demonstrate how new material can be experimentally produced exclusively from light. They literally gathered to collide individual photons with photons using a laser. Of course, we now understand that there are no photons in principle. There are only electromagnetic waves of the ether which can produce matter upon collision they may or may not produce. In any case, as we have observed with you from the very beginning, someone is diligently filtering the information that will be presented to the general public and the one that scientists will work with. After all, scientists beautifully realize that the focus with the observer effect is just a banal deception in which the electromagnetic field played a key role, in which a beam or a bunch was placed. They beautifully understood and sought a way to prove this effect by another method, excluding any influence, but they did not find it. But they created a maximally confusing construction in which you will not understand at first glance. To understand its operation, you have to thoughtfully trace each stage, but usually no one does this. Just like that, scientists beautifully understood that the photon somehow turns into a short-lived particle, that there are no Higgs bosons either, that in fact they got something resembling matter. But to the wide public, they again announced the victory of quantum physics. Well, we will have to figure out with you, after all, what this thing called ether is and what it is eaten with. Labyrinth of mistakes. And at this moment, many researchers stumble again and again, starting from Huygens with Newton and ending with almost any modern physicist, an alternative, a blogger, or just an educated person, sitting with me, for example, in a Telegram channel. Yes, there are many, almost all. I am often asked to look at modern researchers Lovchikov, Atsukovskogo, Grishov, Rybnikov, and a host of smaller researchers. This is connected with the fact that a huge number of people already understand that without understanding the ether, science can no longer move forward. Even official scientists reluctantly use ether in their calculations. But in order not to attract unnecessary attention, They give new names to different manifestations of ether. For example, dark energy, dark matter, Higgs field, Einstein field, just magnetic and electric fields, various bosons, leptons, quarks, gluons, effects of quantum elasticity, an observer, and so on. Most notably, Vladimir Akimovich Atsukovsky seems to attract attention. He can be considered the new progenitor of etherodynamics in Russia, well, at least because he started his activity earlier than all the others. As early as 1964, he defended his candidate dissertation on the topic, Displacement Sensors as Functional Transformers. In the 70s of the last century, under his leadership, several state standards were developed for sets of onboard equipment, aircraft, and helicopters. And then, based on these standards, similar ones were developed in the United States of America. In 1993, he defended his doctoral dissertation at the Research Institute of Aviation Equipment. Active member of the Russian Academy of Natural Sciences, member of the Tsiolkovsky Russian Academy of Cosmonautics, honorary member of the Russian Academy of Electrical Sciences, professor. That is, among all current researchers of the ether, he is the most respected, the most highly educated actor, a real official scientist with a capital letter. Since the mid-90s, he has been actively working in the field of ether wind, has published many works, monographs, translations into Russian of other authors on this topic, and has been actively corresponding with foreign institutions. It was he who introduced the concept of a toroidal vortex, which is now manipulated by anyone who is not lazy. He developed a whole direction of research in science, which is called etherodynamics. It's very interesting that Atsukovsky himself came to the idea of ether not on his own. In his own words, one day he was given a task that turned out to be unsolvable with the help of Maxwell's equations. And then he, Atsukovsky, first of all decided to study how Maxwell himself tried to solve this problem. And it turned out that Maxwell himself initially tried to solve it through ether. But he made a bunch of mistakes, oversights. He gave up and dropped the matter. Atsukovsky, on the other hand, went further and found a solution.
So we have a problem, and how did you approach the broadcast? And very simply, when I encountered the fact that the Maxwell equation cannot be solved, then I went to Maxwell and saw that Maxwell was dealing with the ether, and it became perfectly clear to me that I had to return to the ether. Make sure to review what Maxwell left incomplete. Well, there is no such thing as a man did a job and did everything for everyone. You understand, there is a man with such a philosophical force. First, that Maxwell's ether was ideal, for example. Do you understand? Secondly, it turned out that Maxwell didn't study everything, including darkness. We will cover what he didn't study. Well, for example, doesn't it seem strange that the integral is equal? Well, imagine that. Such a scary thing that it starts to pulsate over time, and here you have a sphere right here. Because it follows that they must pulsate magnetically simultaneously. They cannot pulsate simultaneously, which means there is some kind of delaying process. Where is he? He's not here. And if you take the divergence, the equation is the same. There is also no delay here. Only this spoils the statics and this spoils the dynamics.
But even then, Atsukovsky didn't go any further, being satisfied with the result and deciding that he had found the very ether. Another researcher, Vadim Lovchikov, essentially borrowed the same idea of a toroidal vortex from Atsukovsky. For example, Vadim is more of a talented popularizer than a scholar or researcher. So, if you're interested, I'll leave a link to his channel under the video for you to check out. Much more mysterious is the unexpected death of Vadim Lovchikov. According to official data, he died unexpectedly at the age of 55 from a micro-insult on his own birthday. That is, on the 27th of January, 2021 year. And everything seems, although sad but natural. After the transferred pneumonia, microinsult and all, the man is gone. But few people pay attention to another interesting nuance. He died exactly on the third day after the death of Vladimir Akimovich Atskovskogo. I don't want to say anything, but agree, a very interesting moment. Two men connected by one topic, one theory. One of them is a scholar, a researcher, and the other is more of a popularizer and disseminator of his ideas. They die one after the other in 1 year with an interval of only 3 days. Coincidence, chance, who knows? However, we digress. By itself, many understand that ether exists and they seek it. Atskovskogo's story about this search is very interesting. I'll link to the video in the description again. But everyone, even those who are very eager to find and control the ether, make the same catastrophic fatal mistake. And the thing is, we are all specially trained people, even if we don't consider ourselves as such. Simply because we learn in school from childhood, grind away in institutes. And those who deny everything and look for an alternative are still stuck within the framework of either classical education or the dogmas developed by society. Well, for example, if you're an alternative thinker, then you must necessarily be a flat earther. This is a dogma. We know with you that this is not so, but a dogma is a dogma. Or if you believe in reptiloids, then they are necessarily with eyes, scales, forked tongue, and hissing. This is also a dogma, in fact, and here everything is not so. I have already shown in one of my early videos how reptiloids should really look like if they existed. But a dogma is a dogma. So the same thing happens with the search for ether. No matter how diverse and broad-minded the researcher is, no matter what free views he holds, he still operates within the framework that confines him. If not a classical education, then, at the very least, society. Society wants you to look smart, say smart phrases, show formulas while doing so, and then you might get an audience. Of course, one can take a step a little further, but then everything that modern and not very physics is based on will be destroyed. Well, except for the formulas, of course. They will continue to work correctly. So where does this mistake lie? It's all very simple, in corporeality. Look, Huygens and Newton considered ether a liquid and applied formulas to it based on the fact that it's a liquid medium. Later, Mendeleev and other scientists after him concluded that it's a gas. And Zhukovsky went even further and decided that it's a gas consisting of even smaller particles than the atoms of ether, and these very atoms are made up of them. In modern quantum physics, ether is some kind of analog to a gluon or quark. According to Atskovsky and all other researchers of ether, this gas fills absolutely all space, acts as a carrier of all forces, and penetrates through any matter. Indeed, from this understanding came further logical reasoning, leading to successful attempts, by the way, to trap the ether wind, calculate its direction and speed, and then giving birth to the theory of toroidal vortices and ether-o-dynamics as a whole. In this direction, these efforts undoubtedly have every right to life and development. But this is not ether. Have you noticed what absolutely all these theories are obsessed with? Absolutely all, starting from the assumption that ether is a liquid, then that it's a gas, and then that it's some kind of microgas made of ethers. Absolutely all these ideas in quantum physics with its quarks, gluons, and bosons are obsessed with the same dead ends. No matter how much they reduce the size of the particles that ether is made of, it is still finite. And in the end, we still get one, albeit very small particle. Be it a molecule, atom, quark, photon, operon, or a mirror, it doesn't matter. It's still a particle, which means it's a corpuscle. and that means there's emptiness, nothingness between these particles. This only speaks about one thing. You can't approach the ether from a classical point of view. In basic concepts about microstructure, something needs to be changed. And these are some basic states of matter. Remember, any substance can be in a solid, liquid, or gaseous state. In the last 100 years, a fourth state, plasma, has been added to these three states. These are all basic fundamental states in which any substance, matter can exist. However, none of them are suitable for ether. To explain all the properties of ether, a fifth basic state needs to be introduced. You can come up with any name, but personally, I like the good old ether. In this state of the substance itself, there is essentially nothing. No electrons, no protons, no quarks, no gluons, not even amirs, nothing. Ether itself is one and indivisible. Ether is the very space, the very universe. And it is impossible to find its smallest particle because it is one huge indivisible particle. I'm expressing myself roughly, but I think you get the idea. By the way, that's why some consider the ether to be a crystal. It is one, indivisible, and therefore longitudinal and transverse waves freely exist in it, like in a crystal. However, it has an infinite or nearly infinite ability to compress and stretch. This property allows it to conduct waves of all types and in all directions. Well, if that's the case, let's try to explain some of the fundamental puzzles of physics, starting from this understanding of the ether. Let's go. So, with the entire spectrum of electromagnetic waves, starting from radio waves and ending with hard gamma radiation, I hope it's clear. If not, watch my previous film, Light. What's more interesting, what is a particle? Let's start with the fact that any electromagnetic wave, as it propagates, exerts pressure, and when this pressure accumulates, we register an elementary particle, a quantum, say a photon. Or, as in experiments at the Large Hadron Collider, a superphoton, a superquantum, which was named the Higgs boson. However, it is not a complete particle, since although it has mass obtained as a result of the collision of ether waves. But the glue that holds a real particle in a stable state is still missing. And that's why this quantum self-destructs in a septillionth of a second. For stable matter to be born in the universe, simple collisions of light beams on collision courses are not enough. Something bigger and qualitatively different is needed here. So let's go from the other end. Try to explain what electricity and magnetic field are in general. Well, it's more or less clear with the field. It's the agitation of the ether. This has long been recognized even by scientists themselves and is called quantum fluctuation. But what caused it? And why is any wave in the ether specifically electromagnetic? That is, it consists, as it were, of two waves, electric and magnetic, and they are not separate at all, only together. This phenomenon, or rather the effect it caused, was also noticed by Huygens 300 years ago, and then he assumed the existence of two ethers, one in the other. This was noticed by all other researchers, and Einstein came to the final conclusion that the field is electromagnetic. These are two sides of the same coin, and they go inseparably together. Therefore, the explanation of electricity and magnetic fields should be mutual. Well, let's give it a try. Imagine a wave moving in a homogeneous space where there are no separate particles. It's a whole unified space. Therefore, a wave that goes through this space is forced to stretch it in some places and compress it in others. No matter how infinitely stretchable this space might be, there still arises an infinitely small, yet still a force of resistance, rigidity. I think you're already guessing that in those places where the wave will compress the space, a magnetic field will appear, and where it will stretch, gravity will appear. But we were talking about two waves, one longitudinal, the other transverse. In this case, it doesn't even matter which one of them is which. We've dealt with one wave, the other remains. It will also cause compression and tension along its path, generating a positive charge in the areas of compression of the ether and a negative one in the areas of tension. That's basically it. So, in the universe, four basic fundamental forces are born: gravitational force, magnetic force, and two electric ones, positive and negative. Yes, I know that in modern physics the layout looks different. The four fundamental forces of interaction there are gravity, electromagnetism, and also the so-called weak and strong interaction. However, don't rush. Everything further is already a game with these four forces and their combinations. Now I'll try to explain, and therefore now we can move on to the birth of matter. In the last video, I talked about a mathematical paradox that led to the creation of quantum physics at the beginning of the 20th century. This paradox was named the ultraviolet catastrophe. In short, I'll remind you that the essence of the paradox is that mathematically it turned out that if you increase the frequency and power of the wave, then at some point its power begins to go to infinity, which we never observe in nature. And so, at the end of the 19th century, the best scientific minds were thrown into solving this paradox, which eventually led to the emergence of the concept of quanta and essentially quantum physics. However, if it weren't for this event, we might have learned to control the ether, matter, and substance 30 years ago. After all, in essence, we were already on the verge of discovering materialization. The essence of the following is that the wave, increasing its power by itself, simultaneously increases the four basic forces that accompany it in their power. And at some point, one of the forces begins to take over. Most likely, these are two forces at once, positive charge and magnetic field. Both are born from the compression of the ether space, and overlapping each other, they resonate and form a spatial cocoon, a magnetic trap into which the wave catches itself. In this trap is placed the standing wave, compressed to the limit. Accordingly, they are both considered one electromagnetic force. We consider this cocoon a proton. The outer part of this cocoon is created from stretched parts of the ether space, and accordingly, gravity and a negative charge appear. We mistakenly consider the negative field itself to be an electron. And this explains a lot. For example, why atoms vibrate. Where do they get so much force and energy for infinite vibration at a speed of billions of oscillations per second? And this is simply a wave, having caught itself in a loop and running in an infinite circle at the speed of light, unable to break out of this circle, out of this force cocoon, born of its own power. This also explains the phenomenon that the proton is almost 2,000 times heavier than the electron. After all, the potential of charges seems to be the same, although with different signs, in one case plus, in another minus. But why is the positive charge so much heavier than the negative one? And it's all simple. It is in the proton core that all the mass of the compressed space is concentrated. There are still two fundamental forces of interaction to explain. These are the so-called strong and the so-called weak interaction. The strong interaction, as we know, is responsible for the bond between quarks, gluons, and electrons. Everything here is very simple. Take the same electron, no one has ever seen it. And this annoys physicists so much that they are now seriously asserting something about the field of probability, thus producing an unimaginable amount of new phantom entities. Britva Akama does not approve, in some mystical way. This electron, just spinning around the proton at an unimaginable speed, manages to hold several protons, including neighboring atoms, thus forming molecules. No, seriously, try running around two buses. Can you keep them from scattering in different directions? But we're told that it's the greatest fundamental force of interaction in the universe. But if you imagine that there are no electrons and the field we see is nothing else but stretched ether, which, by the way, cannot be torn apart because it is one and indivisible, then everything becomes clear. It's just some kind of gravitational electrical spatio-temporal coil around a compressed piece of ether. And what about quarks and gluons? They seem to be also related to strong interaction. And why are there only 3 quarks and a proton? No more, no less. It's also simple here. Try to twist a spiral wave. Of course, it's complicated, but there's a discipline in mathematics that deals with something similar. And biologists have long put it to use. It helps to study the structure of proteins, which are made up of DNA and ribonucleic acid, which in turn are also analogous to standing waves with double spirals, sometimes single ones. This discipline is called topology. It can help a lot in understanding molecular bonds, but in our case, we are considering the supercompact wave folding, and the smallest node that can be folded from a spiral will consist of 3 peaks. Each peak will be considered a separate quark. That's why there are only 3 in a proton, no more, no less. That's why even if you try to pull any of the quarks out of the proton, another one will appear in its place right here, as if out of nowhere. No mysticism in quantum chimeras. And the twisted parts of the spiral wave between the 3 peaks of this compressed wave will appear to us as gluon bonds. This was excellently demonstrated by the experiment at the Large Hadron Collider, where proton bunches were accelerated to speeds close to the speed of light. Then the protons seemed to unravel and fill up with new gluons, and generally turned into some kind of diffuse, shapeless cloud. By the way, why did this happen? And here we approach the last fundamental interaction in the universe, so-called weak interaction. It's almost the weakest force in the universe, only gravity is weaker. This weakest interaction is responsible for the decay of electron bonds. That is, some force trying to break all particles apart. Well, it's also quite understandable. Since the ether is one and indivisible, then high-frequency waves, having fallen into the club of their own interactions and unable to break out of it, nevertheless, are an indivisible and inseparable part of this very single ether. Something like loops on the fabric. But since this fabric is continuous and has some rigidity, it tries, albeit weakly, to return to its original state. And that means no matter how small, there will always be a reverse load on the atoms from the ether. But that's not all. These nodes of matter, moreover, are in motion, in constant motion, at a tremendous speed. Because even if you sit still and don't move, even if you're a marble slab in a deep shaft, abandoned 1,000 years ago, you're still moving at a tremendous speed around the Earth's axis, and at an even greater speed around the sun, and at an even greater speed around the center of the galaxy, and so on. Absolutely all atoms are in constant motion at very high speeds. So there's nothing left for the ether to do but to penetrate through atoms, through all these nodes, standing waves, areas of increased and decreased tension, and so on. And it is quite capable of doing this thanks to its superfluidity, superelasticity, superhardness. Nevertheless, it still encounters some resistance from the environment, even if it's in units with 30 zeros after the decimal point. But it's still there, which means there will be that very weak force trying to tear atoms apart. So returning to the experience at the Large Hadron Collider, why did protons begin to stretch in space rather than compress? And the number of gluons in them began to increase out of nowhere? Yes, a wave is just a process, a movement. And when a proton is accelerated to the speed of light, then for a unit of time, such a quantity of ether space begins to pass through the proton that the oscillations of the internal compressed waves simply begin to stretch. The stretching of the ether passing through the proton stretches it, and consequently, the length of the wave increases. It creates a feeling that there are more gluons. Yes, no, it didn't increase, the wave just lengthened. And now we can answer a couple more unsolved questions in physics. Well, for example, what is a charge? It turns out that a charge is simply a degree of compression, a stretch of the ether, a beat of agitation, waves of ether. And what is mass? Mass is the amount of compressed ether. And now it becomes clear without any formulas why in physics mass is measured in the amount of energy. By the script. Well, it's quite possible that all this is just a figment of my imagination. It's a small thing to imagine a universal conspiracy against ether where it doesn't exist. Attempts by world governments to halt scientific progress or steer it in the wrong direction. Or maybe I just revealed to you some great secret that no one has ever thought of. Anything is possible. Perhaps someone will remember Augustin Fresnel, who lived in the times of Newton and Huygens, who also considered ether as a single entity. Lord, how long ago it was, 300 years ago. Since then, there was Newton, Thomas Young, Max Planck, and Einstein. But unexpectedly, just 3 months ago, while making a video about the existence of the soul, I started digging into Duncan McDougall's experiment on the weight of the soul. Remember the famous experiment about 21 grams? But has anyone ever read his entire work? Personally, I've only found snippets of this text copied from one source to another on the internet. So in the end, I found his entire article and fully translated it into Russian. In that video, I showed this entire article with a full screen image. So almost at the end of this text, there are such lines. Moreover, it is assumed that the broadcast is uninterrupted, is a continuous whole, and cannot exist in separate parts as a broadcast. Then as the only basic condition for the continuing personality or individuality, the quality of this as separate and distinct from all things is considered. That's it in a nutshell, so to speak. Duncan McDougall wrote that at the time of his work being officially recognized as doctrine, the ether was still considered, and even then people considered it a continuous whole. I remind you that this work was written in the year 1907. By that time, it had been 7 years since Max Planck had solved the ultraviolet catastrophe, and he had received a Nobel Prize for it. It's been 7 years since quantum physics appeared, 2 years since Einstein published his theory of relativity, and we've entered a new century of discoveries. And some doctor in the United States of America conducting an experiment in search of the soul completely accidentally blurted out that it turns out to be the case at this moment. The most popular theory was still the ether theory, moreover, as a single whole. Say, there is no conspiracy.